हेलो दोस्तों। In this video I will talk about some previous year questions which are asked in csir net in mathematics subject. So this is series. In every week I will upload one video in which 10 or 12 questions may be there. So first question is, we have given a set I which is singleton 1 union is singleton 2 for x belongs to real number. Let phi x be a function defined as like this: infimum of mod of x minus y, where y belongs to I and x belongs to real number. Then which option is correct? We have options are: phi is continuous somewhere on R, phi is continuous in R but not differentiable at x equal to 1, and phi is continuous somewhere on R but not differentiable of at x equal to 1, 2, and D is this. So for to tackle this type of questions, we can draw a graph like this. Graph of this phi x, it looks like this. We can see we have uh, bendingness or V shape at 1 0 and 3 by 2, 1 by 2 and 2 0. So if x equal to 1, 3 by 2 and 2, at that in that situation this function is not differentiable. So we can say D option is correct. Now second question is, we have given a series which is converged to log 2. Then we need to find sum of this series minus 1 power n upon n into n plus 1. So here x is less than 1. If x is less than 1, then we know integration of 1 upon 1 plus x is like this: 1 plus x power minus 1. If we do expansion of this, then we get 1 minus x plus x square minus x cube, like that, like here. Then we know integration of 1 upon 1 plus x is log 1 plus x, and integration of these one. So we will get like this. Like this. After that we go, then we need to find convergent of given series minus 1 upon n minus 1 power n upon n into n plus 1. So we can write this is like this. After that this, so we will get 2 sum as m tending to infinity. Now apply limit both sides. Then this series is converged to minus log 2, and we have to find this. So this is this one. Now add plus 1 and minus 1, then we will get minus 1 plus log 2. Okay, how? Then our option, correct option is no option. That means this is the answer. Now we have given third number questions, which is determinant is defined at R2 cross R2 to R. So we have vector cross product of two vectors, then we have scalar in R. Determinant is defined like this. What is derivative of determinant map at V comma w, where v belongs to R2 and w belongs to R2 in the given direction h comma k, where h is h1 h2 and k is k1 k2. So we need to find derivative, a direction derivative. So what can we do? Determinant of derivative of determinant at v and w, at point v and w with direction h comma k, which is given by this thing. So del u upon del v1 in direction h1 plus del u upon del v2 in direction h2 plus this. So we will get w2 h1, this one, and this is determinant of hw and this is determinant of v comma k. So we can know what is derivative of this determinant function in the direction h comma k. This is the answer. Now convergence of power series. Sorry. Convergence of power series. Power series is given by 2 power minus n z into 2 power n. So we can write this an x power n, where x is z square. Now we know in complex analysis radius of convergence, so we can use that. Radius of convergence is defined like this: 1 upon r equal to this one. So we will get simply 1 by 2. So radius is 2. That means a mod z square is less than 2, then this series is convergent. Now you that fact, mod z square is less than 2, then z is less than root 2. So at the end point z equal to plus minus root 2, we will get. Now we have to find at the end point. We don't know about end point, but we know less than that end point. This radius of convergence guarantee that in that neighborhood strict inequality this series is convergent, but at that point we don't know about that. So for that we have to put that value in this series. So after putting that value we will get this, and we know summation of n equal to 0 to infinity 1. So 1 infinite many times, adding infinite many times 1. So how this will be convergent? So this is divergent series at end point. Now 5 number question. Let fx equal to, we have given function fx equal to mod of cos x plus mod of sin 2 minus x. Find the points at which f is not differentiable. We need to find that point. So f is not differentiable, or if f is not differentiable means what? Either this first function either this first function not differentiable or this second function not differentiable. So both can also happen. Both can also happen. Then we have so at which value this cos x is 0? We know 2n plus 1 into pi by 2. At this value cos x is 0. So at that point this is curve shape and union with sin 2 minus x, at which point sin 2 minus x is 0. So 2 minus x is equal to n pi, which implies x equal to 2 plus n pi or 2 minus n pi. But here minus plus doesn't care because n belongs to z. If here we will write to minus sign, then this will become 2 minus n pi, n belongs to z, so that is fine. 2 minus n pi or 2 plus n pi, both are same in this case. So this is the set where f is not differentiable. Now remark is that every metric distance function So every we know distance function and metric space. What do you mean by metric space? Metric is some property of metric. If distance function satisfy, then we call metric space. So every metric space is distance function, but converse need not be true. So here question is, which of the following is metric? Dxy is minimum of xy, dxy of. We have also seen dxy is mod of x minus y is forms metric space. So this is true. This is easy. Now we need to find why a and c is not true, because if we take d1 0, so minimum of 1 0 is 0, but 1 is not equal to 0. So in metric space we require dxy is 0 if and only if x equal to y, but in this case 1 is not equal to 0. Now second c option, if we take d1 minus 1, this becomes 0, but 1 is not equal to minus 1. So this is counter example for a and c, and b and d is true. You can easily verify that dxy is equal to 0 if and only if x equal to y, and dxy equal to dyx, and third is triangle inequality. That means dxy, what do you mean by triangle inequality? Triangle inequality means dxy is less than or equal to dxz plus dzx. There will be one point at like this. This is. So this distance is less than or equal to this plus this distance. So now which of the following is are correct? N log 1 plus 1 by n plus 1 is converted to 1, and this. So like a option, n log 1 plus, we know what is formula, expansion of log 1 plus x. This is x minus x by square by 2 plus x cube by 3, this one. So here we can apply log 1 plus 1 upon n plus 1 expansion of log. So we will get like this. Now we can multiply n both side. So we n tending to infinity, we will get 1. So first option is correct. Now second option, like similarly we can verify that b is also correct, but for c and d case this is wrong option. First one is going to infinity and c1 is going to infinity, but d1 is going to 0. So this is wrong. Let function be sequence of integrable functions. Fn be sequences of integrable function on closed interval ab. Then fnx goes to 0 almost everywhere. Then this integration a to b fnx go to 0. This almost everywhere. So a b c is not correct. What is counter example for that? Counter example for a is fnx. Consider a function fnx equal to n if x belongs to 0 to 1 by n, and 0 if x belongs to minus 1 by n to 1. So 0 to 1 fnx dx is 0 to 1 by n x dx, which is 1, but in this case it is 0, so not true. Take fnx equal to 1 minus 1, so we will get some, this function is going to 0, but here not. And for counter example for c is this. So here D is correct option. Function are uniformly bounded, true because bounded convergence theorem. So here we used bounded convergence theorem in part D. If f and x are converged to almost 0 almost everywhere, then a to b f and x dx converted to 0. Now 9 questions. Suppose f r2 to r2 fxy is defined like this. check continuity and differentiability of f at 0 0. So we have, this is multivariable case, we have f1 and f2. So for this we can verify Jacobian like dfxy like this, del f1 upon del x partial derivative. So at 0 0 this not equal to 0, so all directional derivative exist along this vector. So this is true. Given function f from real number to real number, so that this is a general case of Lipschitz condition. Like for Lipschitz condition, we need k equal to 1 and this alpha equal to 1. No, k equal to some real positive, but alpha equal to 1. So for all x y belongs to R and for some alpha greater than 0, k greater than the, then which one is true? Every f belongs to f is continuous. This is true because f satisfies Lipschitz continuous function. So for continuity property, we know definition of continuous. So that satisfies clearly here. Because if x minus y is less than delta, then fx minus fy is less than k times delta, which is epsilon. So this satisfies. Is uniformly continuous also. Every differentiable function f is in f. This is not true because Lipschitz condition doesn't imply differentiability. Continuously different, we have some note like this. Continuously differentiable is subset of Lipschitz condition. Lipschitz condition continuous is subset of alpha holder continuous, and this is subset of uniformly continuous. This is subset of Riemann integrable, and this is subset of Lebesgue integrable. Also, Lipschitz is a subset of absolutely continuous, and this is subset of bounded variation. This is subset of differentiable almost everywhere. So we need to put some counter example for C and D. Every differentiable function f is in f. Take fx equal to x square, not uniformly continuous on R. Holder continuous. So if this is not uniformly continuous, then not holder continuous, which implies not uniformly continuous, which implies it not differentiable function, not in f. And for default, fx equal to mod of x belongs to f, this one. So this is some questions, almost 10 questions are there. We will continue in next week. 10 more questions are like this. Okay, all the best.